All right, go ahead and open up your math spiral. I want you to take some notes. This is the lesson 1 and 2 review. There was a lot of stuff in lessons 1 and 2, so I want to go over it and make sure that everybody gets it. The first thing that they started out with was adding and subtracting decimals. The key here, you've got to align the decimals. So I'm going to go over and I'm going to plug this in down here at the bottom, 47.8. All right. I've got to line the decimals up. They've got to be straight up and down, straight above each other. And if you need placeholders over here to make you feel comfortable, go ahead and put a 0 there. Then let's just go ahead and add. You've been doing this all your life. 3 plus 0 is 3. 9 plus 8, 17. Make sure you have the decimal there. Write down the 7, carry the 1. So that's going to be 5 plus 7 is 12. Write down the 2, carry the 1. And that's going to be 6 and 4 is 10. Write down the 0, carry the 1. And 1 plus 3 is 4. So your final answer is 402.73. All right, subtracting. I need to do exactly the same thing. Line up the decimal. So 178.04. All right, and again, if you want to go ahead and add a 0 at the very end so that they match up, go ahead and do that. All right, and we've got to borrow here. I don't know if you guys remember how to borrow. I can't do 0 minus 4. Now you know that 90 minus 4 would be 86, but here's how you do that. I can't do 0 minus 4, so I'm going to borrow 1 from the 9 and make this a 10. 10 minus 4 is 6, and then 8 minus 0 is 8, so I get 86 cents. Same thing over here. I cannot do 3 minus 8, so I'm going to borrow from the 4. I'm going to turn that into a 3 and make this a 13. 13 minus 8 is 5. Uh-oh, I can't do I can't do 3 minus 7, so I need to borrow one more time, make that a 1, make this a 13. 13 minus 7 is a 6, and 1 minus 1 is 0, so my final answer is 65.86. So there's adding and subtracting decimals. Make sure that you line up the decimals. They've got to be straight up and down, one above the other, and everything will work out just fine. All right, let's start off with adding some fractions that have common denominators, really simple fractions. Like I can say, what if I had 1/5 and I wanted to add 2 more fifths? Well, you just add the numerator. You just add the top numbers, and you would have 3/5. Okay? And subtraction works the same way. If you had 7/8 and I wanted to subtract 1/8, that would leave me with 6/8. And remember, you always have to reduce. You got to reduce. Always, always, always. So you got to find out, hey, is there something that I can divide both of these numbers by? And yeah, I can divide 6 by 2, and I can divide 8 by 2. 6 divided by 2 is 3. 8 divided by 2 is 4. So your answer is 3/4. All right. Now look, it's no different if you had a mixed number like this. I'm just going to add, how about 3 and 1/5? I'll use the same fractions. And let's go with 4 and 2/5. Okay? Well, you would add the 3 and the 4, and you'd get 7. And you would add the 1/5 and the 2/5, and you would get 3/5. So your answer would be 7 and 3/5. Okay? So mixed numbers aren't that much different. All right. Let's go ahead and try some that have different denominators and see what happens. Like if I had 1/2 and I wanted to add 1/3. Well, you can't do that. You need a common denominator. You need the bottom number to be the same. All right, so I know if I multiply this times 3/3, that would get me 3/6. All right, so you got to know that 1/2 is exactly the same size as 3/6. They're exactly the same. They might look different, but they're exactly the same. And then over here, I'm going to multiply this one times 2/2. And so this is going to be 2/6. So 1/3 is exactly the same as 2/6. And now that I have the common denominator on the bottom, all I have to do is add the numerators. So 3/6 plus 2 more 6 will give me 5/6. All right. Let's go ahead and do some other mixed numbers. Let me clear this slate right here. And again, you should be taking these notes in your math spiral. All right, let's do something like this. Let's go with 4 1/3. And I want to add 1 1/4. Now again, you've got to come up with a common denominator between thirds and fourths. And the smallest number that could be divided by a 3, and it can also be divided by a 4, is a 12. All right, so here's what we're going to do, and here's the kind of work that I want to see. I want you to show me that you're going to multiply this times 4/4, and you're going to multiply this fraction times 3/3. All right, now over here, nothing happened to the whole number. 4 is still a 4, but I'm going to turn 1/3 into 4/12. All right, and again, nothing happened to the whole number. 1 is always going to be a 1, but 1/4 is exactly the same size as 3/12. So now I can add together my whole numbers. 4 plus 1 is 5, and I can add my fractions. 4/12 and 3 more 12s will give me 7/12. All right, that's not too bad. All right, let's slide over here. I'm going to do the same numbers, but this time I'm going to subtract. All right? So we've already converted these fractions to mixed numbers, so that's going to be easy. Again, I'm going to multiply this. The common denominator between a 3 and a 4 is going to be 12ths. So I'm going to multiply this by 4/4, and I'm going to multiply this one by 3/3. Now the reason you can get away with this, I don't know if you remember, 4/4 is the same thing as 1, and 3/3 is the same thing as 1. And you can multiply anything by 1, and it doesn't change it. It might look different, but it's not going to change the size at all. So here we go. Now I have 4 4/12, and I'm going to subtract 1 3/12. So I'm going to wind up with 4 minus 1 is 3, and 4/12 minus 3/12 is 1/12. So when you subtract these two fractions, you get 3 1/12. All right, let's do some fun stuff here. This one, I'm going to get a fraction that's actually larger than 1. I'm going to get a fraction that's an improper fraction. So I'm going to add 7 3/4 plus 3 5/6. All right. The lowest common denominator between a 4 and a 6 is a 12, because I can do 12 divided by 4, and I can also do 12 divided by 6. So I want the smallest number that can be divided by 6, and it can also be divided by 4. All right, so these are going to be 12ths. So what I'm going to do, I'm going to multiply this fraction times 3/3, and I'm going to multiply this fraction times 2/2. So again, the 7 is always a 7, but I'm going to change 3/4 into 9/12. And over here on the right side, the 3 remains a 3, but the 5/6 I'm going to turn into 10/12. All right, now I can add these together. And look, it might help if I stack them up. 7 9/12 plus 3 10/12. It might be easier to see it this way. The 7 and the 3 gives me a 10, and the 9/12 and the 10/12 gives me 19/12. All right, now it's okay to have a mixed number, and it's okay to have an improper fraction, but it's not okay to have a mixed number and an improper fraction. So here's what I need to do. The 10 is still going to be 10, but I need to change this into a mixed number. 19/12 is really the same thing as 12/12 plus another 7/12. All right, now the reason I'm doing this, I'm pulling 12/12 out of this improper fraction because 12/12 is worth 1. So 19/12 is really the same thing as 1 and 7/12. All right, so I already had 10 over here, and 19/12 is the same thing as 1 and 7/12. So the total answer for this one is going to be 11 and 7/12. Okay, so that's adding some mixed numbers where I got more than 1. My fraction turned into more than 1, so I had to bump up the whole number. All right, I'm going to do the same problem, the same numbers, but I'm going to do subtraction. All right, so again, I started off with 7 3/4, and I'm going to subtract 3 5/6. All right, and again, we've already done this. We've already determined that the lowest common denominator between a 4 and a 6 is a 12. So I'm going to multiply this times 3 over 3. So this is going to be 7 9/12. But we do that because we already did that. And over here, I need to turn 5/6 into 10/12. So this is 3 10/12. All right, again, sometimes kids think that it's easier to see if I stack them up like this. All right, so here's the deal. You know, I could do 7 minus 3, that's no problem. But oh, this is a problem. I cannot do 9/12 minus 10/12. I don't have enough to subtract from. All right, so here's what I'm going to have to do. I'm going to go ahead and I'm going to borrow 1 from the 7. And that's going to turn in, the one that I just took away, that's going to turn into 12/12. Okay? So now, here's what I have. Instead of 7 9/12, I have 6 21/12. All right? And down here on the bottom, nothing changed. I still have, I'm going to subtract 3 10/12. So here we go. Now that I've got enough 12s up here on top, I can go ahead and subtract 6 minus 3 on the whole number. That's going to be 3. 21/12 minus 10/12 leaves me with 11/12. And that's your answer on that one. All right, so that's enough review on fractions, adding and subtracting fractions. I think we should go ahead and move into long division. We're going to change fractions into decimals, and we're going to use long division. All right, I want to convert the fraction 1/8 into a decimal. All right, this really means 1 divided by 8. And now a lot of kids, when they do this the old-fashioned way, long division, they write this down backwards. But the 1 goes on the inside, and the 8 goes on the outside. This is 1 divided by 8. All right, I'm going to need some decimals over here. I'm going to need some placeholders. And it doesn't matter how many zeros I put to the right of the decimal. It doesn't change the answer. I mean, this is 1, whether it has no zeros or 10 zeros after the decimal. All right, and what I want you to do is line up a decimal right here at the top and just start dividing. 1 divided by 8, can't do it. So now I get to slide over to the second number, 10 divided by 8. Well, 8 goes into 10 one time, and then 1 times 8 is 8. So now I get to subtract. 10 minus 8 is 2. And I always get to drag down one more number to the right. Whatever my answer was, I get to drag down the very next number, and only one more number. All right, so now I have 20, and I'm going to divide by 8 again. I'm always dividing by 8, the number on the outside. 20 divided by 8, 2 times, because 2 times 8 is 16. So again, subtract. Before I do anything else, subtract. 20 minus 16 is 4. I get to drag down the very next number, which is 40. So now I do 40 divided by 8, and this is going to be 5, which is great because 5 times 8 is 40. And when I have no remainder, that's called a terminating decimal. So 1/8 is exactly the same as 0.125 And this is a terminating decimal because it stops. To terminate means to stop. Okay? All right. Make sure that you get these down. I'm going to delete it so I have more room to work. And we're going to do one that hopefully is repeating because I want to do one of each. So on this one, I'm going to say 9/11ths. This is really 9 divided by 11 because fractions are just division problems. It's the top number divided by the bottom number, the numerator divided by the denominator. And again, here's where you have to be careful. A lot of kids write these down backwards. But the 9 goes on the inside. The numerator goes on the inside, and the denominator goes on the outside. All right, 9 divided by 11. Again, I can't do 9 divided by 11, so I'm going to put some zeros over here, some placeholders, and I don't know how many I need. I'm just going to load it up. All right, so again, 9 divided by 11, can't do it. Slide on over, 90 divided by 11. Looks like that's going to go into it 8 times because 8 times 11 is 88. You want to get as big as you can without going over. Now I do 90 minus 88, which gives me a 2. I bring down my very next number, which is a 0. So now I have 20 divided by 11. 11 goes into 20 one time because 1 times 11 is 11. If I went 2 times 11, that'd be 22. That would be too much. You can't do that. You got to go as big as possible without going over. And now I do the subtraction again. 20 minus 11 is 9. Drag down the next number, which is a 0. So 90 divided by 11. Doesn't this look familiar? That was the very first step. 90 divided by 11 is just like the very first problem that I did here. 8 times, because 8 times 11 is 88. Subtract, you get a 2. Bring down the next 0. 20 divided by 8. Well, that looks familiar too. It looks just like this part. 20 divided by 11 is 1, because 1 times 11 is 11. Subtract, and you get the 9, and another 0. And this is just going to keep repeating. It's just going to keep doing the same thing over and over and over. All right, so what we have is a repeating 8, 1, 8, 1, 8, 1, 8, 1. So 9/11ths is equal to a repeating 0.81. And that is why it's called repeating, because it's the same pattern that repeats over and over and over and over and over. Okay? All right, then the next thing that we did, lesson 2, and then the next thing we did on lesson 2, we talked about absolute values. We talked about positive numbers and negative numbers. But the main concept here was graphing on a number line. All right, so we're going to take some, let's start off with some easy stuff. If I've got like a -3, all right, let's say I've got a -3 and I want to add 7. All right, I want to start at 0. Always start at 0. And you go back 3 places. I'm going to go back 1, 2, 3. There's a -3 right there. There's my -3. And this is my new resting point. And now I want to go +7. So I'm going to go 1, 2, 3, 4, 5, 6, 7. I'm going to go all the way over here. 7 places. And I'm going to find out that that lands me right at 4. Okay, so I know this is easy. This is kid stuff. It's nice and easy. But I want to do a couple of examples just to make sure that everybody understands this. All right, let's do another one. What if we had, what if they were both negative? What if I had a -3 and a -7? Which, by the way, is exactly the same thing as -3 minus 7. Okay? Adding -7 is exactly the same thing as subtracting 7. So in this case, both of these numbers happen to be negative. So again, I'm going to start at 0, and I'm going to go back 3 places. There's my -3. All right, so here's my new starting point right here. And I'm going to go back another -7. Whether I add -7 or I subtract 7, that negative sign means I'm going left. So I'm going to go back 7 more times. So I'm going to start right here, and I'm going to go 1, 2, 3, 4, 5, 6, 7, and I'm going to land right here. So there's my second number, -7. So a -3 and a -7, they're both negative, so they're both going left. I'm getting even more and more negative. So the answer to this is -10. All right, so the secret here is when the two numbers have the same sign, I've got a -7 and a -3. They're both negative, so they're even more negative. They're working together. They're both going left. On this one up here, when I have two different signs, I've got a negative number and a positive number. They're working against each other. They're heading in opposite directions. All right, so this should be pretty easy. Hopefully this is all review. All right, let's do the double negative. Here's where a lot of kids get messed up. The double negative. If I go 5, well, first of all, I'm going to go 5 minus 8, and we'll see what happens. All right, if I start at 0 and I go 5, so I go all the way over here to 5, there's my first number. That's a +5. And I have to put it in reverse. That's a -8 minus 8, so I have to go left 1, 2, 3, 4, 5, 6, 7, 8 times. I have to go left 8 times. All right? So, since the signs were different, that's a +5 and that's a -8. You could also write this like this, a +5 and a -8. I wind up back here at -3. So there, the answer to 5 minus 8 is -3. All right, but here's the deal. What if I had 5 minus -8? All right. One negative sign means go left. Then here's another negative sign. That means shift directions again. So this one says, well, I should be going left, but another negative means I have to change directions and go right. And here's the way I want you to think of this. When I remove something negative, I'm adding it. All right, so up here, it was -8. I'm subtracting 8, which means go left. But down here, this says, let's subtract a negative number. Let's remove a negative number. So this really means 5 plus 8. I don't know if your elementary teacher told you this. Whenever there's a negative, a minus and negative right next to each other, plus them. Just turn them into a plus. So minus minus is equal to plus plus. All right, but only when they're right next to each other. Only when they're right next to each other. I'll show you what I mean in just a minute. But anyway, so let's go ahead and do this one. I'm starting at 0, and the first number is a +5. So I'm going to go over here, +5. And since I'm removing a -8, minus -8 really means +8. I'm going to go 8 more over here, and I'm actually going to run out of numbers. 11, 12, 13. I got to go 8 places over here. Here's my new starting point at 5. 1, 2, 3, 4, 5, 6, 7, 8. I'm going to land all the way over here because minus -8 is really +8. And I don't know if you've ever seen that before. So the answer is +13. All right. Let's do another one. Let's start off with a negative number, -9. And let's subtract a -4. Okay? All right. Again, a lot of kids are going to think, well, that's a -9 and that's a -4. But wait a minute, we're subtracting a -4. We're removing a -4, which really means we're adding 4. So I'm going to start off right here at 0. My first number is -9. So my first line goes all the way back over here. That's a -9. But minus -4 is really the same thing as +4, plus. So this means I need to go back right 4 times. So I'm starting right here, and I need to go right 1, 2, 3, 4. So that puts me over here, and the answer is -5. All right, so this is really the same thing as -9 plus 4. So I went left 9 places, and then I went right 1, 2, 3, 4. So the answer to this is -5. So I want you to think about this. Every time you see a negative sign, it means go left. It means go the opposite way. So if this was a 9, I would go 9 places to the right. But since that says -9, I'm going 9 places to the left. All right, for my next move, this minus sign or negative sign will make you think, well, I've got to go left again. But this one makes you change directions again. So 2 negative signs in a row minus a negative number really means plus plus. All right, let's make sure that you have all of these notes in your spiral notebook. And I want to make sure that your diagrams look just like mine. So should we do one more? Let's do -3 minus 2. All right, nice and easy. Again, always start at 0. And -3 means go left 3 times. All right, so that's a -3. And here's my new starting point. -2 or -2 means go left 2 more times. And then this tells me my answer, -5. A -3 and a -2 is a -5 because they're both negative. They're both negative numbers, which means that you're going to combine forces and they're going to be even more negative. All right, so hopefully this will help you with your review packet.